Hi, Lex. Hi, Marisol. Where's Elijah?
He had to work.
I'm writing a report for my finance class using percents. I have an idea that I want to run by you guys.
Show me.
I have numbers for how many people clicked on a company's website for 3 years running. I want to focus on 2016 since that's when they rolled out a new product. I'm trying to say stuff like clicks in 2017 were 30% higher than 2016, and the clicks in 2015 were 20% lower than 2016. Those are the real numbers. I got the idea from my grandma's utility bill. Check this out. This is from her gas bill.
Sounds like a good format for your report. What's the problem?
I was checking the calculations for my report by doing them another way, and they didn't check out. Neither did the percentages in this bill.
Show us your calculations.
The bill says that she uses 20% more than efficient neighbors. That's saying that 360 therms is 20% more than 300 therms.
What's a therm?
It's a unit of the heat energy in gas.
To do percent more than, you find how much more, then find the percentage of the whole. We're comparing to efficient neighbors, so the whole is 300 therms. 360 therms is 60 more than 300 therms, and 60 out of 300 is... Divide 60 by 300.
0.2, which is 20%.
That checks out with what the bill says.
Here's where it messes up. If my grandma uses 20% more than efficient neighbors, then efficient neighbors use 20% less than my grandma, right? But if you do the calculations, it doesn't work. The efficients use 60 therms less than 360 therms. 60 divided by 360 is 0.167, which is about 17%.
It's close, though. Let's try with the average neighbors and see where there's a bigger difference.
The difference between your grandma and the average neighbors is 540 therms minus 360 therms, which is 180 therms.
180 divided by 540 is 0.33333. Your grandma uses about 33% less than the average neighbors.
But if you compare average neighbors to my grandma, the whole is 360 therms. 180 divided by 360 is 50%. The average neighbors use 50% more gas than my grandma. That's definitely not just a rounding error.
I think we did the calculations right.
Yeah, I think so.
Lex, could you make another copy and mark some percentages? For your first calculation, you said the whole was 300 therms, the amount for efficient neighbors. Draw a vertical line at the end of the efficient neighbors bar and write 100%. Now make another copy and mark 100% at the end of your grandma's amount. The difference, 60 therms, is the same in both diagrams, but the whole is bigger in the second diagram. So that same 60 therms is a smaller percentage of a whole.
Oh, I see. The percent depends on what you say 100% is. If your grandma's gas is 100%, then the difference between her and the average neighbors, 180 therms, is 50% of your grandma's. This piece is half of your grandma's bar. But if the average neighbors are 100%, then the same 180 therms is only 33% of the average neighbors. That same piece is a third of the average neighbor's bar.
Exactly.
Oh, so we can say the average neighbors use 50% more than my grandma, or 50% more than 360 therms. Or with the same two numbers, we could say that my grandma uses 33% less than the average neighbors. The whole is different depending on who we're comparing to.
Wait, I remember something from my math class where you can do percent increase faster by multiplying by 100 plus the percentage. Something like 7% more is 107%. Elisha had a good way of explaining it.
I can text him. Okay, so I'll tell him I'm with Lex and Marisol, and Marisol says you have a good way to explain percent increase, like 107%. Can you help? Oh, he's on his break. So he said if you buy something and there's 7% tax, then you have to pay for 100% of that thing's cost, plus 7% of that thing's cost, and that makes 107% of that thing's cost.
Makes sense.
The distributive property.
Oh.
Oh, now he sounds like he's been reading the math book. Oh, he says Marisol can draw a good picture. And he's gotta go. I'll tell him that thanks, that he really helped.
Marisol, can you draw a picture of 107%?
This bar is 100% of whatever you have. This little bit on the end is 7% of what you have. Together, they're 107% of what you have.
I was thinking you can't have more than 100% of something, but you can if it's a comparison to something smaller.
Lex, go back to your screen with grandma as 100%. Make lines for 50% and 150%. See, the average neighbor uses 50% more gas than your grandma, or 150% of your grandma's amount. Here's how it works for your grandma and the average neighbor's 4% of. You just divide. Divide the average neighbor's gas by your grandma's gas. 540 divided by 360.
1.5? Huh?
Make it into a percent by moving the decimal point 2 places to the right.
150%. That's the 50% more from before, plus 100%, like Marisol said.
How would that work for the other direction, where your grandma uses 33% less?
Let me try. What Marisol just did was a comparison by dividing. So I could just divide in the other order. 360 divided by 540.
About 0.67. That's 67%.
That's a percent decrease. 100% minus 67% is 33%. My grandma uses 33% less than the average neighbors. Or we can also say she uses 67% of the amount the average neighbor uses.
It's also a third. Your grandma uses 2/3 of what the average neighbor uses, which is the same as 1/3 less.
This seems to be mostly about multiplying and dividing. So you divide, and it tells you how many times as much.
Divide 540 by 360, and it says average neighbors use 1.5 times as much gas as my grandma.
And if you divide in the opposite order, it says your grandma uses 0.67 times as much gas as the average neighbors.
Would the same idea work with addition and subtraction? If you subtract 540 minus 360, it says that average neighbors use 180 therms more than my grandma.
If you subtract in the opposite order, you get negative 180?
Negative 180 more than is the same as 180 less than.
When we said percent more than and percent less than, we were combining comparisons that used multiplication and addition. No wonder we were so confused.
I guess we really needed the distributive property.
Now I know how to check the percentages in my report. And I'll include bar graphs with lines too.
We're so smart.
Mm-hmm.